you've probably have had someone tell you the importance of having a strong password so that people can't break into your sensitive accounts. And they tell you some rules of thumb. They might tell you things like no words, where a word would be something in the dictionary or a proper noun, people's names, people's places, cities, things like that. You'll also hear people will tell you to use a variety of characters. A variety of characters. And when they're talking about that, they're saying, don't just use numbers, don't just use lowercase letters, don't just use uppercase letters, don't just use special characters, use a combination of all of the above. So for example, when we talk about special characters, we're talking about things like the exclamation mark or the @ symbol or the hashtag. And so use that in combination with numbers, in combination with upper and lowercase letters. And then the other thing people will tell you is that the length of the password matters. So longer password is good. Now, what I want to do in this video is really appreciate why these, I guess we can say, rules of thumb matter. And to think about that, we just have to think about how a password can be broken. So if a human being is trying to snoop around, and so let's say this right over here is the thing that's trying to break the password. So in this case, it's a human being. What would they do? Well, they would just try out password number 1, and maybe it doesn't work. And then they would try out password number 2, and then maybe it doesn't work. But they would just keep on doing that until maybe they get to password number, maybe a human being could go up to maybe 100, and maybe eventually they are able to find the password. And it would surprise you how frequently people use passwords that could be guessed in this short a period of time, because they use passwords like the word password, or they use their username as their password, or they use their password 12345 or 123456789, or something that is very, 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 or they use their date of birth, something that is very, very guessable. And in that situation, even a human being might be able to try it out in a reasonable amount of time and stumble upon the password. Now, as you can imagine, human beings are not the only things that are trying to break into people's accounts. A malicious individual could write a malicious program that is trying to do this, and programs are much, much faster at trying out all of the possibilities. But you might say, hey, look, in the English language, if you look up, in the dictionary, there's roughly about 200,000 words. And then if you include proper nouns and different verb tenses and all of the rest, you're going to 1 million plus words. And you might say, well, surely, clearly a human being couldn't try out all of these possibilities, and it probably would take a computer a long time. But you have to remember how incredibly fast computers are. Probably in your pocket, you have a smartphone, or even maybe a not so smartphone. So let me just make this clear. So a computer and your phone, or most people's phones, are now computers. A computer can do in excess of 2 billion instructions per second. Instructions per second. And this number is by Moore's law, which you could look up as a fascinating dynamic in the computer industry. This is doubling every 18 months. So even a fairly inexpensive phone can now do 2 billion instructions per second. And it doesn't take that many instructions for them to try out a new password. So you can imagine that a computer could actually try out all of these possibilities fairly quickly. There might be some things slowing it down. It might take some time to test out the password, or they might have to interact with some other system. But it would not take a computer a long period of time. And a computer does not get bored, and a computer can be very, 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 very persistent. Fair enough. So now I've convinced you, don't use words. Now, what about this whole idea of using a variety of characters? And to think about why a variety of characters, and frankly, why longer passwords are good, we just have to break out a little bit of our high school mathematics, and remember a little bit about how many possible passwords, or the number of how the number of passwords increases as we use more characters and we make a longer password. So, for example, if you had a 1-character password and you only use numbers, there would be 10 possibilities. The 1-character password, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, or a 0. Now, if you had a 2-character password, so each of these little blanks I'm putting here is one of the characters, then the first one could have 10 possibilities, the second one could have 10 possibilities, and so you have a total of 100 possibilities for a 2-character password that only uses numbers. Now, if you were to go all the way to an 8-character password that uses only numbers, so let's do that. So 3, 4, 5, 6, 7, 8. So I'm going to take 8 tens and multiply them together, which is the same thing. If we remind ourselves about what exponents mean, that's 10 to the 8th power. That is 1 followed by 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. So there's 100 million possible passwords, 8-digit passwords where we are only using numbers. So once again, you might feel pretty good about that, but look at this number, 2 billion instructions per second for even a fairly inexpensive computer. We're not talking about a supercomputer or a whole bank of computers someplace. Just saying, okay, I kind of see that. But one thing you do appreciate immediately is every time that you add another character, even if you're limiting yourself only to the numbers, to the digits 0 through 9, every time you increase a character, you're increasing the number of possible passwords by 10. So if you have a 9th character, now all of a sudden there are going to be 1 billion possible passwords. So that's why we have the idea that the longer the password, the better. Now, why does using a variety of characters help? Well, then there's more possibilities per character in this password. So if you have an 8-character password, so that's 4, 5, 6, 7, 8, and let's say you would extend it to letters and numbers. So there's 26 letters and there's 10 numbers. So that would be 36 possibilities for the first one, 36 for the second one, 36 for the third one, 36 for the fourth one, so on and so forth. And then you would multiply those 36s, which is going to give you a much bigger number. Or if you were to even extend it even further, if you were to say, look, we have 10 numbers, or I guess we could say we have 10 digits. We have 10 digits. We have 10, and there's actually more than 10, but let's say the easy to get to special characters right over here. So we have 10 special characters. There's actually more at your disposal. 10 special characters. You have 26 lowercase letters and 26 uppercase. So now if you use this as your arsenal for each of the characters of your password, that gives you a total of, let's see, this is 52 plus 20. That gives you 72 possibilities for each of these blanks. And now things get they get big faster. You get more possibilities faster as you add more and more characters. So for example, now we are talking about a scenario where every time you add a character, if you pick from this arsenal, 72 times 72 times 72, every time you add a character, you get 72 times as many passwords. And so let's see, that's 872. So that's 72 to the 8th power, and I'm going to need a calculator for that one. That is 72 to the 8th power, which gets us to, and I won't write this whole thing, roughly 7.2 times 10 to the 14th power. So this is, let me write this, approximately 7.2 times 10 to the 14th power. And just to give you an idea of this is roughly a 7 followed by, or this is approximately, we could say this is approximately a 7, and then you have a 2, and then we have 13 more zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 zeros. So now we are dealing with, let's see, this is million, this is billion, 720 trillion possibilities. Did I do that right? This is million, billion, 720 trillion possibilities. So when you expand it this way, you have now gotten, so if we divide that by 100 million, so let me do that just for fun. This is actually quite exciting. So if you divide that by 100, that's 100,000. So 100 million. Make sure I got that right. 1, 2, 3, 4, 5, 6, 7, 8. Just by increasing your arsenal of characters, you have 7 million more possible passwords. So it would take someone or a computer 7 million times longer to break your password in this situation, assuming it isn't one of the easy low-hanging passwords to guess. And every time you add another character, it increases the number of passwords by 72. So hopefully this gives you an appreciation why people give you these rules of thumb when you are selecting your password.